What's up, team? Today, made a short video, quick video of the things you need to know to be successful on quiz number 1, talking all about properties of exponents. So let's start with the basics. What the heck do these exponent things mean? We're going to start in general, we're going to get specific, and then we're going to talk other properties. So first things first, I'm not going to do these top to bottom. I'm going to do the ones that are simpler, and then we're going to try to figure out the rest of them. So x to the first power, that's just x. So that one's nice and easy. X to the second power, well, that's x times x. And x to the third power, that's just x times x times x. So these exponents, or these powers, are just little shortcuts, little shorthand of telling us how many times are we multiplying x by itself. This time it's just once. Here it's twice. Here it's 3 times. Okay, let's look at the negatives real quick. We're going to skip the 0 for the time being. X to the negative first power. Well, that's super similar to x to the first power, except for it's the inverse. It's just flip-flopped. So instead of x over 1, it's 1 over x. And the same kind of thing is true with x to the negative second power. It's 1 over x times x. Okay, so notice some patterns here. The x's in the bottom they're getting more x's in the bottom as we get more negative, getting more x's here as we get more positive with our exponent. Now this x to the 0th power, this throws people off. This is kind of a funky one. Notice if we have x to the third power and we divide by x, we get to x to the second power. If we divide by x again, we get x to the first power. If we divide by x again, we get 1. And then if we divide by x, we get 1 over x. If we divide by x again, we get 1 over x times x. So that 1, it seems out of place. It seems out of character. But it makes sense when you think about it, because if you're getting the exponents are getting bigger, you're just multiplying by x each time, and x to the 0th power is going to be 1. That's true for every number ever. Anything raised to the 0th power is always 1. So you might see a problem like that. Okay, let's get specific with these 3's now. Let's kind of apply what we just talked about. 3 to the negative second power. That's the same as 1 over 3 times 3, or 1 over 9. Okay. 3 to the negative first power, that's just 1 over 3. 3 to the 0th power, well, anything to the 0th power is 1, so this one is also 1. 3 to the first power is 3. 3 to the second power, 3 times 3, which is 9. And 3 to the third power, 3 times 3 times 3, which is 27. So this is basic overview of exponents. What if you're multiplying them in a general sense with any sort of numbers? I use x, y's, and z's. These could be anything. They could be numbers as long as the bases match, as long as the big letters or big numbers match. All of these rules will remain true. So multiplication, x squared times x cubed. So this is x times x times x times x times x. Well, now all of a sudden we have 5 x's we're multiplying together. So this is just x to the 5th power. Notice that all we really had to do, the shortcut here, is do 2 plus 3, x to the 5th power. Let's check this one out. Same kind of thing. Y times, well, 5 of them. 2, 3, 4, 5. Now we have 6 of them, so it's y to the 6th power. Again, 1 plus 5 here is 6, so this is y to the 6th power. Let's check this last one out. This last one has y's and z's. This is y squared times y to the 3rd power times z to the 1st power. So we can only combine the ones that have the same base, in this case the z's. So the y to the 3rd power, that remains untouched. We still only have 3 of those. But the z's, I'm noticing there are 2 of them here, and let's put the y's in here, and then the z. So we have 3 y's, and we have 3 z's. So it's z times z times z. The same ideas are true here. We did the 2 plus the 1 to get the 3, and here the y to the 3rd power, that just stayed to the 3rd power. So this is how you multiply exponents. Division, similar but different. Instead of adding exponents together, you can do some subtraction. This one here, x to the 3rd power over x. Well, this is just x times x times x over an x. Remember canceling. Here we can do an x divided by x, which is just 1. 1 times x squared is just x squared. Another way you can look at this is 3 minus 1 is 2, so x to the 2nd power. You'll probably see something big like this on the quiz with different letters, different numbers and stuff. and we just need to keep track of all the pieces. So I would look at the x's first, and then the y's, and then the z's. So here I'm noticing there's an x to the first power on top and x to the fourth power on the bottom. The bottom number is bigger in this case, and there are 3 left over. So you're doing 1 minus 4. So let's just do the x portion by itself. Up here we did 3 minus 1, and we got x squared. That one is nice and simple. Now the bigger number is in the bottom. So this one would end up being x to the negative third power, which is the same as 1 over x to the third power. So that's this, it's this idea here, but it's one higher, x to the negative third power. Same idea though. So in our denominator, we're going to have x to the third power. Great. Now forget about the x's. We're done with the x's. Let's look at the y's. We have y to the second, y to the first. Notice the bigger numbers on top. So our y is going to be on top. 2 minus 1 is just 1. Boom. Now our z's. Z to the fifth over z squared. Here we have a 5 on top, a 2 on the bottom. 5 minus 2 is 3. So we're going to have a z to the third power on top. Again, the x one is in the bottom because the exponent for this x is the larger one is in the denominator. So we got x to the negative third power, and of course we simplified it here. Okay, I'm going to set up one more type of problem, and then we'll wrap this up. Okay, we're going to talk powers of powers, or I like to call them piggyback powers because it's like one's giving the other kind of a piggyback ride. It's weird, but that's what sticks in my head. Okay, so we have x squared in this case. So all that means is we're doing x squared times x squared, because that's what the square tells us to do. We're multiplying the stuff inside parentheses by itself. In this case, it happens to be x squared. Well, we just did something like this a few minutes ago. X squared times x squared, you're going to add the 2 and the 2, you get x to the fourth power. The shortcut here is noticing that we have a 2 and a 2, just multiply them together. 2 times 2 is 4, and that's how we get this x to the fourth power. Okay, that pattern remains true down here. The long way to do this one would be x, y to the third power, z to the fifth, that's an exponent fifth, times x, y to the third power, z to the fifth, times x, y to the third power, z to the fifth. Well, we can add up how many x's we're multiplying, how many y's, how many z's. I see 1, 2, 3 x's. I see 3, 6, 9 y's, and z's, 5, 10, 15 of them. Just counting up our exponents. Another way to do this, to get the same exact answer, here's the shortcut. Again, you're just doing the same multiplication we did earlier. It's kind of a sort of like distribution, sort of. So you're multiplying the 3 times the 1. So that'd be x to the third power. That's where this comes from. Then it's 3 times the 3, y to the ninth power. That's why we got this 9. And then 3 times this 5, z to the 15th power. That's how we got the z to the 15th power. So this is the long way, not necessary unless you really want to do it. The shortcut way, you're just multiplying the exponents by the one on the outside of parentheses. This last one, we're going to do the shortcut way. We're going to, at each individual chunk in here, we're going to can distribute this to. Distribute, I'm using that language loosely. It's not technically distribution. So we're going to take it here, 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 and here. 3 to the second power. That's 3 times 3, so it's 9. X squared squared. 2 times 2 is 4, so we're going to have x to the fourth. The y's now. 1 times 2 is here. Z to the 10th power. 10 times 2 is 20. Z to the 20th power. Now we're all done. This is how you would compute powers of powers or piggyback powers. Okay, if you understand the stuff here, you're in really good shape to retake quiz number 1. If you run into questions, watch it again, slow it down, speed it up, do whatever you need to do. And if you're still stuck, ask me questions. I'm happy to help. All right, you got this.